Okay, so next we want to figure out a way of computing the boundary homomorphisms in the chain complex defined in the CW chains on a CW complex X. So we want to understand what those are. Well, you know by definition what these two abelian groups are. They're these homology groups of these quotients. One skeleton collapse the previous. And by a lemma stated earlier, part A of it, in fact, asserted that each of those in turn was free abelian on the set of cells in the CW complex for X. So the assertion in this theorem is that the boundary homomorphism is the homomorphism between these free abelian groups, which is, well, you know, to say what it is, you just have to say what it does to the generators here. In other words, to the each element alpha in I sub n. And so the assertion is that the value on an element of I sub n, so on an n cell, alpha is, now I need to name a linear combination with integer coefficients of the elements in the set of n minus 1 cells. And it's this linear combination. It's the formal sum indexed by the set of n minus 1 cells of some integer coefficients in front of each. So to know what this is to know ultimately what this entire homomorphism is to know for each alpha what these coefficients d sub alpha upper beta are. They're some integers. And finally, what the statement then is that d sub alpha upper beta, those coefficients in these linear combinations, or said another way, the beta row alpha column integer in the matrix codifying dn is simply the degree. And that's why we talked about degrees earlier. It's the degree of this composite map between spheres. It's a map between n minus 1 spheres. It goes from the boundary of the alpha cell by the defining attaching map from it to the n minus 1 skeleton, followed by collapsing the n minus 2 skeleton. The result here, you know, is homeomorphic to a wedge of n minus 1 spheres, as we've talked about before. And you can collapse all wedge sum ends to the base point except the beta sum end. And that beta sum end maps onto here as the identity map. So there's this collapse map C for collapse sub beta. So there's this composite map. And it's the degree of that composite map. We'll see some examples that compute this degree. Okay, so that's the theorem, and here's the proof. Okay, we want to compute this d sub n. It's defined as this composition, so we will have to use that, no surprise. And we're saying we're asserting what its value on alpha is. Well, let's see. So the inclusion of the alpha n cell into the n skeleton, I sub alpha, I for inclusion, induces a homomorphism on homology groups, and therefore, after you quotient out, so there's this homomorphism is induced by the continuous map on topological spaces from that quotient to that quotient, given by the map from the n disk, the defining map from the n disk to n skeleton, in terms of the attaching map from its boundary to the n minus first skeleton. So there's that upward arrow. This is free abelian on a single generator, which I'm calling alpha. And what this statement is asserting is what d sub n is, at least when you precompose by this map, I sub alpha star. Well, these long as x sequences are compatible with respect to continuous maps of pairs. In particular, this map is the Friday term of a long as x sequence, whose Monday terms are these. And so we have this commutative solid square here, where this map is the map from the boundary n to the n-1 skeleton, which is the attaching map, or the map induced on homology from the attaching map. So there's this commutative diagram here. And a simple analysis that we've talked about before when we came up with our inductive calculation of the homology of spheres revealed that this boundary homomorphism is in fact an isomorphism. Therefore, to know in this assertion what the composite I sub alpha star followed by dn is, it's sufficient to know through this isomorphism what this composite is, that followed by this. Now, this is free abelian on the set I sub n minus 1. And so to know to pluck out these coefficients is to apply the collapse map, or the induced map on homology from the collapse map, and look at the resulting integer. So, in other words, the value of d sub n on the alpha in here, at least the coefficients in front of beta here, can be computed as this composite map. And this composite map, phi alpha, followed by qn minus 1, followed by collapse map, is precisely this composite. And the definition of degree was the value of a continuous, the value on 1 of the map induced by homology from the continuous map between spheres. So that gives it to us.